nombres. Just kidding, this isn't a Spanish video. I'm Ayers.
And I'm Anna.
And we're going to teach you about electromagnetism.
Today we're going to teach about the basics of electromagnetism, starting with electricity, magnetism, electromagnets, generators, and Earth's magnetic field.
Let's get started with the basics of electromagnetism. First we begin with the basics of electromagnetism. Electricity and magnetism. Electricity and magnetism are basically the same thing, moving electrons.
In review, electrons are negatively charged particles that are a key component to the atom.
This movement of electrons going from atom to atom is called the flow of electrons. The difference between electricity and magnetism is their flow of electrons.
Now let's get back to electricity. Electricity! Electricity!
Electricity!
Electricity is when electrons move from atom to atom down the line, creating an electrical current.
The flow of electrons in an electrical current is similar to the flow of water in a water current. On the other hand, magnetism is when all the electrons move to one side of the atom. This creates a negative side and a positive side. To have a magnet, you need to have opposite poles, positive and negative. Here we have a magnet. On one side of the magnet are the electrons. This creates opposite poles, so a north pole and a south pole. It's more visible on this magnet, a north pole and a south pole. When you put the opposite poles together, they attract. But when you put the same poles together, they repel. Here's a close-up of our north and south poles. When the same poles are close together, they repel. But when the opposite poles are together, they attract. Now, there are three types of magnets: permanent, temporary, and electromagnet.
The whiteboard is a temporary magnet, while this is a permanent magnet. Before the magnet sticks to the board, all the electrons and the protons are just everywhere and they're going crazy and there's no particular order. But then when the positive side of the magnet touches the whiteboard, all the electrons move up front to greet the positive side because opposites attract. This is a permanent magnet. At the beginning, permanent magnets were just like temporary magnets, but a super strong magnetic force got all the electrons to move to one side and all the protons to move to the other, creating a negative and positive side. But temporary magnets require permanent magnets, while permanent magnets are always magnetic.
Now let's roll on over to electromagnets.
Electromagnetism is electricity used to create a magnet. It can be simple or complex.
A basic electromagnet requires a wire and a battery, and an iron core for the wire to wrap around. Now, let's look at the battery. A battery is formed by creating two opposite sides. The positive side is called the cathode, and the negative side is called the anode.
The positive side of the battery is full of protons, while the negative side of the battery is full of electrons. Now, to keep the protons and the electrons from coming together, you have to have a buffer in the middle of the battery. In this case, it's the battery acid.
When you connect a wire to both sides of the battery, it allows a path for the electrons, which are attracted to the positive particles, to travel through. In order to get to the positive particles, the electrons jump from atom to atom along the path of the wire until they reach the positive particles. For instance, if this is a zoomed in picture, these are the atoms, and these are the electrons jumping.
Electrons move from atom to atom down the line, just like leapfrog. The battery stops generating electricity when the electrons run out or the wire disconnects. Now, with the following materials, let's make an electromagnet.
First, you will need a nail as your iron core. Next, you will need 2 black stoppers. Third, you will need at least 2 battery clips to attach to your battery. Then you will need at least 1 yellow wire to attach your batteries. Then you need 1 very long wire to use to wrap around your metal core. You need then at least 1 battery. First, for our first trial, we're going to wrap the red wire around the metal core 20 times. You're going to use the black stopper to hold the metal wire onto the core. Oh, now that we're finished wrapping as shown, we're going to use the other black stopper to keep them in place.
I actually need to edit.
Like so. Now we're going to take our battery, place it in the holder with these 2 on each side facing outwards. This will help the flow of electrons. Now, we're going to connect each side of the wire to the board. Now that we've attached all the wires, this is now an electromagnet. Watch as its magnetic force picks up the paper clips.
To make an electromagnet stronger, you can either add more solenoids or coils in the wire onto the nail, or you can add another battery or another one to give the electromagnet more force and more power to pick up more paper clips. But today we are going to add another battery. Now we unhook this wire from this side of the battery, and we put another battery right here. Make sure that both sides are facing the same direction. And you add 2 more battery clips right here. And then this yellow wire comes in. And this yellow wire is used to connect the 2 batteries. Now that we have more power, the electromagnet can pick up more paper clips.
To make the magnet even stronger, we can add more solenoids. Now that we've added 20 more solenoids, the magnet is able to pick up 4 paper clips.
To add more power to our electromagnet, we're going to add another battery. So we've already hooked up the wires to the battery, so the electromagnet should work perfectly.
But how, you may ask, does this turn into a magnet? Well, when an electrical current runs through a wire, an electromagnetic field is created around it.
The more electrons that are present, the strength of the magnetic poles within the electromagnet will decrease or increase.
By wrapping the wire in a tighter coil, the electromagnet grows stronger. Stronger.
Stronger!
It is it's able to attract more magnetic objects.
In many ways, electromagnets can be better than permanent magnets.
First of all, electromagnets can be turned on and off by starting and stopping the flow of electrons. For instance, disconnecting the wire from the battery.
The strength of electromagnets can be changed while the strength of permanent magnets are constant.
The opposite poles of an electromagnet can be swapped when you change the flow of electrons. Now, we move on to bigger things!
Earth is essentially a giant electromagnet. This magnetic field protects our planet from solar radiation.
Why, you may ask, does the Earth have an electromagnetic field? Well, in the center of the Earth is molten iron. When the Earth rotates, as it is right now, this iron splashes around.
And as the molten iron is moving around, the electrons are moving with it, so it creates electricity. And according to all laws of electromagnetism, if you have electricity, then you have a magnetic field.
Here's where it gets a little complicated.
The geographical poles of Earth are opposite to the magnetic poles of Earth.
This means that in the geographical north, the magnetic south lies, and in the geographical south, the magnetic north lies. But you see, these poles are not aligned. The magnetic pole is at a tilt.
This is why, if you take a compass and follow it all the way north, you'd end up at the magnetic south, not the geographical north.
Because the compass is a magnet, it's attracted to the magnetic poles of Earth, not the geographical ones. These poles are always moving. At some time in the future, these poles will reverse so that they line up with their geographical poles. This has not happened for a very long time, but will happen in the future. Here we have our chart of magnet comparison. First, let's compare whether they turn on or off. Permanent magnets cannot turn off. They are permanently magnetic. Earth's magnet can turn off, but it's not likely. An electromagnet can turn off, whether that means by disconnecting the battery or the wire. Now let's move on to strength. Can a permanent magnet change strength? No, they permanently have the same amount of strength. Earth's magnet can change strength. It is very similar to an electromagnet. An electromagnet can also change strength, whether that be by adding solenoids or batteries. Next, a permanent magnet cannot swap poles. The Earth, on the other hand, can swap poles, along with an electromagnet. As we said earlier in the video, Earth may swap poles sooner or later.
Finally, let's talk about generators.
Generators require 3 parts: a magnet, a wire, and movement.
So, how does a generator work, you may ask?
Well, when you place a magnet near a wire, the electrons in the wire will either attract or repel basing on the pole that faces the wire.
So, if the negative side of the magnet is close to the wire, the electrons will repel. But if the positive side is next to the wire, it will attract.
As you move either the wire or the magnet, the electrons in the wire will begin to move. This movement generates electricity.
So, how does the generator work, you may ask? Blooper!